Welcome to our exploration of the periodic table and its fascinating properties. Today we'll discover how elements are organized and how their properties change in predictable patterns. The periodic table is one of chemistry's greatest achievements, organizing all known elements by their atomic structure and revealing amazing patterns in their properties. We'll explore 5 key periodic trends: atomic radius, ionization energy, electron affinity, electronegativity, and metallic character. This shows Dmitri Mendeleev, who created the first widely recognized periodic table in 1869, arranging elements by atomic mass and predicting undiscovered elements. Let's start with atomic radius, the distance from the nucleus to the outermost electrons. This property shows clear trends across the periodic table. As we move across a period from left to right, atomic radius decreases because increasing nuclear charge pulls electrons closer to the nucleus. As we move down a group, atomic radius increases because we're adding new electron shells, making atoms larger despite increased nuclear charge. The effective nuclear charge Z effective equals the actual nuclear charge Z minus the shielding constant S, explaining why atoms get smaller across periods. This diagram shows how atomic radius changes across the periodic table, with the largest atoms in the bottom left and smallest in the top right, excluding noble gases. Now let's examine ionization energy and electron affinity, two properties that describe how easily atoms gain or lose electrons. Ionization energy is the energy required to remove an electron from a gaseous atom. It increases across periods and decreases down groups. The first ionization energy equation shows an atom losing one electron to form a positive ion plus the removed electron. Electron affinity is the energy change when an atom gains an electron. It generally becomes more negative across periods, meaning atoms more readily accept electrons. The electron affinity equation shows a gaseous atom gaining an electron to form a negative ion, releasing energy in the process. This graph illustrates how ionization energy generally increases across periods, while electron affinity becomes more negative, both reflecting stronger nuclear attraction for electrons. Electronegativity measures an atom's ability to attract electrons in a chemical bond. This property is crucial for understanding chemical bonding and molecular polarity. Electronegativity increases across periods from left to right because atoms have stronger nuclear charge to attract bonding electrons. Electronegativity decreases down groups because bonding electrons are farther from the nucleus and experience less attraction. Fluorine is the most electronegative element with a value of 4.0 on the Pauling scale, while francium is the least electronegative. This color-coded periodic table shows electronegativity values, with the darkest colors representing the highest electronegativity in the upper right corner, and lightest colors showing lowest values in the lower left. Metallic character describes how readily an atom can lose electrons and exhibit typical metallic properties like conductivity and malleability. Metallic character decreases across periods from left to right as atoms become better at holding on to their electrons due to increased nuclear charge. Metallic character increases down groups because outer electrons are farther from the nucleus and easier to remove. This creates a clear diagonal divide on the periodic table between metals on the left and bottom, and nonmetals on the right and top. This periodic table highlights the metallic character trends, showing metals in blue on the left side, nonmetals in red on the right, and metalloids in green forming a diagonal boundary between them. Let's summarize all the periodic trends we've learned. Notice how they're all interconnected and explained by the same underlying principles of nuclear charge and electron shielding. Across periods, atomic radius and metallic character decrease, while ionization energy, electron affinity, and electronegativity increase. Down groups, atomic radius and metallic character increase, while ionization energy and electronegativity decrease. Electron affinity shows less predictable trends. Understanding these trends helps predict chemical behavior, bond formation, and compound properties. The periodic table truly is a powerful tool for understanding chemistry. This comprehensive summary shows all 5 periodic trends on one diagram, with arrows indicating how each property changes across periods and down groups, revealing the beautiful patterns in the periodic table. Thanks for learning about periodic trends. Like and subscribe for more chemistry content, and let us know which periodic property you find most interesting in the comments below.